All right, well, let's talk some more integration by parts. We're live, baby. Where did I put it? Let's see if you can see that. I think you can see that. All right. So did you start working on the problems from integration by parts? Were they scary? Yeah? I mean, they should have been a little bit scary. Like, I mean, there should have been, I mean, I would not be surprised if you struggled a little bit. That's totally okay. There's a term that we use in math education called productive struggle. And sometimes productive struggle is actually a very good thing. Like, you having an experience struggling on that, and then coming in the next day and then like talking through it can be very powerful. It can also be frustrating because you feel like, you know, but if you change your mindset a little bit and think this is a process of learning, not like this isn't a process of testing how smart I am, that'll help. So, was there anything like glaring that you want me to do? Like any of the problems that you're like, whoa, how do we do this? I don't want to do all of them, but I mean, we have a few options here. I can do more examples, or I can work out some of the ones if you got through. I mean, how many of them were there? Like 15? There were 23 of them. Yeah. So if you got like 10 of them on your own, I mean, I'd say you're in a pretty good spot. If you got 0 of them, then we probably need to like go back to the drawing board. So where are we there? I mean, how many of you think, oh yeah, I can take a quiz on this right now? Yeah, I didn't think so. I mean, you just want me to make one up and see how we do? Yeah, sure. Okay, ready? Well, let's do this. Well, there's 2 types I want to make sure we hit today. Let's try this. How about x squared e to the 2x? We're going to work on these problems that I gave you, tonight too. So are we in the camp of using f, g prime, and all that, or are we in the camp of u and dv? Okay, I'd say some of you you're probably going to be in both places. And I'd say it'd be good if you're comfortable with both. The book, I believe, uses u and dv. So if you're looking at examples in the book, that's how they do it. It really doesn't matter. I like probably introducing it to you with f prime and g because it makes more intuitive sense when you think about we're treating one of these as a function and one of them as a derivative. And with dv, that is just clunky. But then once you understand that that's how it works, I feel like it's shorter to use u and dv. It's cleaner, I guess. Not shorter is not the right word. Cleaner is better. So I'm going to say this is f and g prime, right? That's how we would do that. So what do you think? What's our choice for the function? What's our rule of thumb? Our rule of thumb is we let f or u be something that gets simpler when we differentiate it, and it's easy to differentiate. X squared, right? Now, honestly, even the 2x is also pretty easy to differentiate. Okay? But when you've got a polynomial and an e to the 2x together, you don't want to make the e to the 2x the u, because you're going to start going in circles. Okay? Now, if you've got e to the 2x combined with something else, that might be a different story. Okay? So we're going to make u equal x squared and dv e to the 2x. So what's du? 2x, and then I'll stick the dx here. And then what's v? Okay, so now the thing with integration by parts is you got to be able to do that antiderivative pretty snappy. That's not something you have to sit. You have like the luxury of sitting around and pondering. You know what I mean? You got to be able to look at e to the 2x and say, oh, that's e to the 2x over 2. Okay. Now, where did that come from? Why is it over 2? Well, because when we went from here to here, we did like a little u substitution. Okay. All right, so now we use our formula, uv minus the integral of v du. Okay, and let's clean this a little bit. What happened to them 2's? They cancel, and then I'm going to put this like that. Is that hot air coming out of there now?
No.
Yeah.
Sometimes it's kind of cold though.
It's hot now though. It's weird, when I stand over there, I can actually, I felt like it's getting hotter in here. I was worried I was getting a fever. Okay, so now what? Friends, now we're stuck. Because normally, all the examples that we did up till right now, that integral is something that's easy to do. It ends up just being like e to the x or sine of x. But we don't just know that. Okay? Well, can I use a u sub to do this one, Meg? I could use a u sub to do this one if that were x squared right there.
Oh.
Okay? So in this case right here, guess what we're going to do? We're going to do integration by parts again. Okay? And so this is how I do this. Like for when I do this, when I have to integrate by parts multiple times, this is what I do to help with the bookkeeping. You know what I mean by the bookkeeping, like keeping it nice and organized? See this minus? He's very important. Like very important. So I put minus, and then I put a big, like, bracket to remind me that that minus has got to be distributed through when we're all done. All right, so I'm going to set it up again. Now, technically speaking, if someone were a real jerk, they might say, you can't use u and dv there because you already used them before. Like, I'm not going to do that. No. That's stupid. Okay? So what is u going to be? X. dv is e to the 2x. What's du? 1 dx. What's v? The same thing it was a minute ago. E to the 2x over 2. And so now we've got u times v minus the integral of v du. I'll just put dx there instead of 1 dx. All right, so last integral. What's the antiderivative of e to the 2x over 2? E to the 2x over 4. Okay. Now I see Megan thought it was e to the 2x because she thought those 2's were going to cancel. Didn't you?
No.
Oh.
I was just thinking we revert back to the derivative of b.
Oh, you went the wrong way.
Yeah.
Oh, okay. All right, so here we go. Ready? Our final answer here then is going to be this minus all of that. So when I distribute that negative, it's going to be x squared e to the 2x over 2 minus x e to the 2x over 2 plus e to the 2x over 4 plus chips. Okay, integrating by parts twice. Now I'm just curious if you see this. What if the original problem would have been x cubed e to the 2x?
What do you have to do in this one?
We'd have to do it 3 times. Okay? What do you think? How do you think the answer would be similar? Do you see really, I mean, the answer is going to be almost exactly the same, except there's going to be another term on the front. Because if we would have set this up, what would have been our u if that was x cubed? What would have been our u? X cubed, right? So our first term would have been x cubed e to the 2x over 2. And then it would have essentially been the same problem afterwards. Okay? There is a shortcut to this that I will show you probably tomorrow, which I call it like rapid fire integration by parts, rapido. But I'm not ready to show that to you yet. Questions on that? You want to do another one? Yeah. So you guys ready? How many of you think that our choice for u is x cubed? That was so amazing. How do you like? I mean, that was the biggest like. You're like, I'm out. I love the conference. Well, why do you think that? Because it's what I mean, you're using your brain. Like, I mean, I think those of you that didn't raise your hand either have already done this, a problem like this, and figured it out, or 2, just because of the nature of the way I asked that question, knew that that wasn't the answer. So Colin, I gotta give it. You're Colin, right? Yeah, I gotta give it to you for being like, hey, I'm following what I've done. I know I'm doing what I know, and it makes perfect sense to want to make u x cubed because it gets simpler when you differentiate it. It's almost always going to be that, except when x cubed is hooked up with a natural log. Natural logs make great u's. I would say in almost every situation, if there's a natural log involved, that's going to be your u. Okay? Natural logs make great u's. So, if I set this up for you, if I set up the parts, can you guys finish it? If I set it up the parts, you guys finish it. Try it. Oh, it looks like Noah joined us. Oh, but Noah you can't see the whole board. I just noticed. Uh-oh. You gotta remedy that situation. Okay, that's better. Let's pump this up a little bit. Oh. Okay, so you ready? All right, Abdel, what's DU? Beautiful. What's V? Beautiful. Okay, now technically there's a dx here, but we're not going to cut your hand off if you forget it. So here's our formula. Ready? U times V minus the integral of V du. Now what? Beautiful. Okay. Don't get caught up thinking I got to integrate by parts again. Look for easy algebra to do. Okay. Someone who's maybe inexperienced might look at that and think, oh, crap, I got two things being multiplied together again. I'm going to have to integrate by parts. No, because that simplifies really nice. Like Megan just said, it simplifies to x cubed over 4. And then what's the antiderivative of x cubed over 4? X to the 4th over 16. Plus the chips. We bought a bunch of bags of chips. So good. What kind? These are from Kroger. They're private selection brand. And they are black truffle and pepper. Black truffle oil and pepper. They're delicious. They're wavy. You know what I mean? What?
How much did you pay for this? Only Kroger, that's expensive.
No, they were my wife said they were like $1 a bag.
That doesn't sound like Kroger.
Black truffle oil and pepper. And cracked pepper, I think is what it's called.
Kroger brand chips.
Yeah. Private selection is Kroger brand. Yeah. I think I might have some in my lunch today. I'll let you try one.
Oh, do we have to eat lunch in here again
Oh
for the session?
yeah. Like,
Did you put me in the 100 fly? I'm so excited to be part of sectionals.
did I put you in the 100 fly?
100 fly, do you guys in that?
No, I didn't think you were in that. You're in that?
Yeah.
I thought you were swimming the 500.
Really? Wait, that's cool. I'm
Yeah.
not doing that.
I thought we were swimming at 500. That was what was happening in the text exchange. I thought I wasn't paying that close attention, but
No, they put me in the 100 fly, which I've never done a 50 fly, so this is gonna be interesting.
yeah, 100 fly just to go out and swim that for the like.
I know.
That sounds rough.
I might drown. Yeah.
The stroke.
But Dale swam 100 fly on Saturday.
Oh, I died. I didn't even.
He died. You just swam the 2 I am, literally, like not
Yeah,
like.
and they didn't have a break between.
I know.
was like, yeah, no way.
Yeah, the no break was awful. Like,
Yeah, Bernie was upset about that.
yeah, I mean, she was yelling at one of the officials like during the right after it. She's like, "I just tanked our 100 butterflyer." She's like, "You know." Yeah. But it is what it is. There'll be a break this time.
Yeah.
What's the fastest swim meet I've ever been a part of in my entire life?
Yeah.
On Saturday. I mean, that was faster than any dual meet. That was faster than like a summer meet. Although those aren't fast. So I guess it's... Other questions here, friends? What about one of the ones on the homework that you're like, what do I do?
Too
A
many.
lot of them. Yeah.
Well, some of you might have to go back and look at it again. Ellie, what are you thinking?
Did you do the inverse of the sine?
Oh my gosh, that's one of them. What kind of jerk would give you that problem? The inverse cosine. Integrate that by parts? Like this?
Inverse cosine is 2x.
Oh. So, I mean, in all honesty, you don't have any choices here. Like, your U and your dV are pretty much set for you because there's only one function there, right? So, U is going to be inverse cosine of 2x, and dV is going to just be dx. So, what's du? And what's v? Well, this is x, right?
Wait, I thought it had to be 1.
Well, okay, 1 dx. And so it's 1x, right? Okay? She was like really kind of what are you talking about? Okay, what's du here? So that'll be 1 over the square root of 1 minus 2x squared times 2. That's a pretty heavy chain rule that we had to do inside there. Right?
Is that negative?
Thank you. It is. Who said that? Thank you. It is negative. So here we go. UV minus the integral of v du. I forgot dx up there. Stick it there. So that'll be x times 2 over the square root of 1 minus 4x squared, if you want to do it like that. So that'll be x cosine inverse of 2x minus the integral of 2x over, sorry, I forgot the negative again. This negative should have been right here, I guess. So I'll stick it right there now. If you want to go ahead, you could right now go ahead and marry those guys and make them a positive. But it doesn't matter if you want to wait. Okay? So how do you do that integral right there? And we grab that. Just say you are. Oh my gosh, it's a cordless phone. Hit talk. This is like 2021. We don't know how to use a cordless phone.
They hung up.
Oh. Did you mean like what do I say or how do I actually work this
I really
phone?
didn't know how to answer it.
Do you have a phone in your house?
No, we got rid of that like.
How many of you don't have a phone in your house? Like a real phone? Amazing.
We got rid of it when I was like third grade.
Yeah.
I was like,
Amazing. This is actually a monumentous occasion for me. Like, there was a kid who didn't know how to work the phone. So how do you do this right here? How do you do this integral? It's a U sub. U is 2x. Oh, wait, sorry, no, it's not. It's 1 minus 4x squared, yeah. Where's my eraser? I'll finish this out just so you see it. And you can look at it online.
Could you put that 1/4 outside right away?
What?
Can you put that 1/4
Yeah.
outside?
In fact, yeah. Let's add 1.
Hi, Mr. Ritter.
See ya.
How was your weekend?
My weekend was
All right, I guess. How was yours? Really stressful. Saturday night, going home from work.
Oh.
There's no good way to go home from the days and all. When the roads are bad.
Are you one that works at Outback?
Yeah.
Yeah. What time did you go? Have to? Those were. I got off at like 9.
Yeah, I got off at 8 and stuff.
Yeah, I was asleep on it.
Hey, where are you?
Friday, after I got home, I slept until 11 somehow. I don't even know what happened.
I tried to do it. Yeah. Just try my best.
I mean, I thought I went this road, but maybe I didn't. Sanitize yourself.
What?
I can't hear you.
I said, what'd you end up writing your English thing? The thing about the ice?
Oh, of course. Why? What'd you get? I got it actually. Go through. Oh, is he gonna get back there? Hmm? Is he gonna get back there?
See what happened was Friday.
Are you gonna go? Yeah, the year that I didn't think
Look at you.
was.
What does a star mean?
It means I couldn't finish it.
Oh, okay.
Yeah.
Ooh,
Yeah, I tried.
what does that say?
Natural.
Oh,
And then after.
is that sine of natural log of 2x?
Yeah. I read it down.
There was nothing else there?
I don't think so.
I mean, off the top of my head, I don't know if I can. Just, I don't see it right away without trying. Most of these I can see right. That's not to say that I couldn't do it. I don't see it right away out.
I did that one though. I probably messed up that one.
We were gonna do one on time. How did you figure that out?
I just guessed.
Well, I mean, you know. So here's our quizzes. Look at me, I got perfect on this. Samuel. Nicole. Nicole. Which one? Village.
Yeah.
Oh, is that the one that's like down by 35?
Yeah.
Oh yeah, you can find some good stuff there.
I know. My friend Molly and I went there one time, and like she really wanted this jacket that we saw, but this lady was like looking at it. So we were just like walking by and forth waiting for her to leave, and she thought we were trying to steal it.
Oh, that's weird. But yeah, that place you can score big, or it could be a big bust.
Yeah, true.
I mean,
That's all first stores, really. The village is one of my favorites.
so the scores on this quiz were kind of like all over the place. You had a lot of scores in the high teens and several 20 out of 20s, and then a lot of scores in the low singular digits out of 20. So yeah, I kind of is what it is, I guess. We're gonna go over that real quick, and then we'll start talking some more integration by parts. How's everybody doing? How was everybody's weekend? Yeah? Is that a new sweatshirt? Are you in DYS? Is that meeting now?
Yeah, they've been meeting since like August,
Virtually?
in person.
No kidding. Where do you guys meet and practice?
I think it's Jewish Temple. I'm not sure what it's called. In a while, I think.
Yeah, LL Academy.
Yeah, that's
Do you do it too?
Yeah.
Are you guys just spread out like really far apart?
Yeah, we're split into two groups so that we have more space to work with.
Wow, that's great. It's good that you guys are able to do that. I wish my kids would practice their violin. I probably shouldn't say that. We're on live. I think my older daughter actually is leaving her violin here in my room over the weekend and not taking it home. And I think you're get graded if you leave it, like they dock you if you leave it at school.
I don't think the name is Eve. I don't think she does.
No, she doesn't have Miss B. I'm not sure who she has. I don't know. I had Miss B as a student. What?
Oh, wait, you mean? I got confused for a second.
No, like you thought I had her,
Yeah,
like she was my teacher.
I don't know any of your teachers' names, but I realize she's probably the really young
I don't, how old is she? I'm not sure. I mean, I can't remember when I had her in class. I can picture her handwriting. I mean, I can picture her name on a paper, like right now. I mean, I can clear as day. She had very nice print. Oh, let's go over the answers to this. So here we go. Number one. So we got this x over 2 minus x squared. So this is a u sub. These are all u subs, by the way. Du is negative 2x dx. So du over negative 2 is x dx. It's over there. So that's negative 1/2 natural log of u plus the cheaps, negative 1/2 natural log of 2 minus x squared plus the cheaps. Okay. Number two. So u is sine of 5x. Du is 5 cosine 5x. So du over 5 is cosine of 5x dx. Got that guy. So this is 1/5 integral u cubed du. An antiderivative of u cubed is u to the 4 over 4. So this ends up being u to the 4th over 20, or sine of 5x to the 4th over 20. Plus the cheats. Number 3 was a homework problem that we actually worked out in this class. You remember? The answer to that ends up just being 1/3 times the natural log of the denominator. And I think most of you got that one right. Now, the back page here, like I said, a lot of scores in the high teens, and the people who scored in the high teens, most of the time it was just a careless mistake. They like, forgot about this 2 here, or they forgot to the 5 and the 4. Those people are the ones that scored in the high teens. If you really missed one, just flat out missed one, most people either miss number 4 or number 6. Okay? These were the most common, just flat out missed. So number 4 looks very scary. But it turns out it's actually not too scary. If I let u equal 1 plus 1 over x, remember 1 over x is the same as x to the negative 1. So the derivative of this u here is just 0 plus negative 1 over x squared, or negative x to the negative 2. And look at that. That's right there. So this integral just becomes u cubed negative du, which is negative u to the 4 over 4, or negative 1 plus x. Now, there were a couple cuties out there. I can't remember if anybody in this class was a cutie who did this problem without doing a u sub. And they did it right. They just expanded 1 plus 1 over x. They cubed that out. Then they multiplied each one of those terms by 1 over x squared. And then they found the antiderivative of each term. And I didn't even check their answer to see if it was equivalent to my answer. I just gave them, I was like, well, if you went through all that work, you need to avoid use of like, but I mean, doing it that way is kind of like using a hammer to put a thumbtack in a bulletin board. And it gets the job done. Yeah.
I had to go before, so I just went back to it, and I couldn't figure out which one it was to use of it first, so I just did it by brute force.
Yeah, I mean, that's it. That's what we call that. And mathematicians, that's exactly what they would call that, is doing that by brute force. It's like, I can't think of any other method here other than the long way. So I know the long way is going to work, so I'm just going to do it. But okay, number 5. Where is it? Number 5. Oh, number 5 was a homework problem. I think we went over that one in class too. That ended up being the natural log of the natural log of the natural log of x. And then number 6. Okay, number 6 is this one. Yeah. So some people were like annoyed with this problem because they're like, I didn't know how to do that problem. The ones that we had in class are on our homework problems. There was something other than a 1 there. You had to factor it out, right? This is actually easier than that, I think, because you don't have to factor something out of a term that doesn't exist. But you just have to think of it like this, my friends. And if you think of it like that, it's so much easier. So u is 5x. du is 5 dx. So du over 5 equals dx. 1 over the square root of 1 minus u squared du. 1/5 du, sorry. So that's 1/5 inverse sine of u, or 1/5 inverse sine of 5x plus 2. So guys, like we got if we didn't do well on this, I mean, we have some time to fix that, but the time's running out. Okay, I mean, theoretically, all of these problems you should have been able to do before you even took your exam. You know, we had a quiz on U subs a while back, and then we had our exam, and your exam only had one problem on it that involved the U sub, if I remember. But now that's not really negotiable, I guess, because you know, U subs are one of many techniques of finding antiderivatives. And that's what we're learning right now, techniques of finding antiderivatives. In fact, it's very often that you will have to do a U sub within an integration by parts problem. In fact, it's on your homework. So we gotta work on this. If we're not there yet. I have full confidence that you can get there. I mean, totally. It's just going to take some what's the word? What? Elbow grease. I'm not really sure the origin of that expression. Oh, it's the other way around. Interesting. But yeah. So, you guys want to talk about integration by parts some more?
Yes.
Yeah? Bipartisan integration. So there are about 20 problems that you had to do. Now, there is no way, if you did all 20 of those over the weekend and got them all right, like I might as well clock out and go home because you don't need me. You're probably not going to need me the rest of the year. Like, you can do all 20 of those solely on your own. Okay, we just learned this. We're going to spend some time on this. I would have expected, though, that you probably would have gotten a handful of them. I mean, I think if you would have sat down and tried, you would have gotten a handful of them. So let's do this. Let me just give you a couple. Let's just do a couple in class today and see how we do. These aren't necessarily on the homework. These are just more like it. Now, last period we did a different one. We did x squared times e to the x. This time we're doing x squared times sine of x. But they're both done very similarly. So, was there one like this on the homework?
I accidentally did like one of the ones where you figure out use of, so I didn't find it because I parked it, and I like that with X, but. So,
There was x squared times cosine. So this is going to be done almost exactly the same. All right, you ready? So,
It's 15.
most books like tell you the section at the top of the page. This one doesn't. So you have to like literally look at that. What number did you say? No, the one that you said was had the log. Oh, it's 23. It is. Okay. Might have to just work that one out. All right, here we go. You ready? So let's set up. How many? I'm just curious. How many of you are in the like? I'm ready. I'm good with using U and DV versus F prime and G and G prime and F and all that. Okay. I'd say you want to get there at some point. I think it's nice to introduce to you and to teach you the technique of integration by parts using F and F prime and G prime, because it just makes more intuitive sense, because that's how you learn the product rule. But when you're actually doing integration by parts over and over and over again, it's just cleaner to use U and DV. It's less messy. Now, you don't have to be clean, and you can be messy if you want. So if I use U instead of F and G prime, U is going to be x squared and dV is going to be sine of x. Okay, now why did I choose that? Because I know that x squared's derivative is easy to do. And I know sine x's antiderivative is easy to do. Okay, also x squared's derivative gets simpler when I do it. That's always another helpful thing. Okay, so here we go. du is 2x. And what's v? Negative cosine. Okay? So now we do the formula. uv minus the integral of v du. So that's going to be negative x squared cosine of x minus the integral of negative cosine x times 2x dx. Technically, there's a dx there that I didn't write. Yeah.
Can you bring out that negative 2 and put it to just plus 2 the integral?
Absolutely. I was gonna do that. Okay. anytime you can marry two negatives and make them positive, go for it. Okay? Integration by parts, honestly, is as much of a bookkeeping exercise as it is a calculus. It's just keeping organized and keeping track of everything. Okay? So these two negatives, Samuel wants to marry. I now pronounce you positive. Okay, so 2x cosine x dx. You could bring out the 2 as well. Now, I'm not on this one, and I'll show you, I'll explain to you why I'm not in a second. But you could. It's all about how you end up dealing with that 2. Okay, so now you're here. And when you're here, this is a little different than the ones that we did on Friday. Why? Well, that's kind of the conclusion. How is this different? Like the other ones, we could just do. Like we would get to that second integral, and it was just something we could just do. Like we just did it. It was like e to the x or sine of x. Okay? But this one, I don't just know this. Okay? And in fact, this I have to integrate by parts in order to do that. So you're going to integrate by parts again. All right? So when you integrate by parts again, to help with the bookkeeping, this is what I do. Okay? I put this term here, like, because he's still got to be there. And then I put a big, like, bracket there. Just to remind me that whatever is here is going to get distributed through that bracket. So sometimes this might be a negative. So that negative would have to get distributed too. Or in Samuel's case, he wanted to pull this 2 out. Okay, if he pulled this 2 out, there would be a big fat 2 sitting there that's going to have to get multiplied through. Okay? I'm choosing not to pull that 2 out because I can deal with the 2 inside here. Okay, it's 6 1/2 dozen the other. All right, so we're going to integrate by parts again. So what's u? 2x. dv is cosine of x dx. What's du? 2 dx. What's v? Sine of x. So now I've got u times v minus the integral of v du. And now I've got to do that second integral. Can you just look at this one and do it? What's the antiderivative of sine of x times 2? Or what's the antiderivative of 2 sine of x? Well, you actually did it up here. It's negative 2 cosine of x. So you got to be careful here, right? Because that minus and that minus, here's this minus right here. This minus is from the antiderivative. Those two minuses are going to hook up. Okay? And then now, the final answer is going to be this plus this plus this. So, negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus chips. Yeah.
Just so we don't get ourselves stuck in like an infinite loop if we do it wrong. Like, what's the max number of like integration by parts that we'll see on like practice problems or quiz test?
Well, let me answer that question after I say this what I wanted to say. Okay, so we see what we did here. Now Alex is thinking kind of big picture, which I like. And so I'm going to come back to that question. But before we answer that question, I want you to tell me what would have happened in this problem if that was x cubed instead of x squared. If you can answer that question, then you understand what's going on. What would have happened if that was x cubed instead of x squared? Nicole, what are you thinking? You'd have to integrate by parts a third time. And not only that, I bet you could tell me how the answer, the final answer, would look compared to this. If you really think through, if this were x cubed rather than x squared, the final answer is going to be almost identical to this, but what's going to be the first term instead? It would be x cubed cosine of x, or negative x cubed cosine of x. Okay? And then these signs might have switched. Okay? So theoretically, to Alex's question, it is Alex, right? Okay. To Alex's question, like, you know, if that was x to 100, well, then you're integrating by parts 100 times. Okay, am I going to make you do that? No. That's stupid. Okay, I probably wouldn't make you do it more than 2 or 3 tops. Okay? But Alex also saw the possibility of getting stuck in a loop. Okay? How would that happen? How would you get stuck in a loop? Okay, and that's I'll probably bring that up tomorrow. I'll probably show you that example tomorrow. There's probably one on your homework that does that.
Because that happened to me when doing the homework a few times. I actually got stuck in a loop.
It's going to happen when you have an exponential and a trig together.
Is there a rule to this, or do you always have to do it? Like, is there ever going to be a scenario where you could look at it and just get it without even doing the integration network?
Well, tomorrow I'm going to show you how this problem we could have done like that. It's a shortcut. I call it rapido. Like, you know, rapido, like Spanish. And some people will make an argument that that shortcut technique is not integration by parts, and they won't let you do it. But I'm fine. But the problem with the rapid technique that I'll show you tomorrow is it doesn't always work. So,
is it obvious that it doesn't work, or does it just like look like it's correct and then it's not?
no, I'll tell you when it works and when you should. Okay, let's do another one. How about this one? Now, if you're paying attention, if you've been paying attention so far, you might agree. How many of you want to make ux squared? Or how many of you want to make f of x squared? That seems like the natural thing to do, right? Because it's like what we've been doing. You're doing what you know, right? And I would say most of the time that's a great idea. The only exception to that is you're not going to let u be the polynomial when he's sitting next to a log. Okay? Natural logs make great u's. In fact, almost any time a natural log is in the problem, that's going to be where your u is. Okay? Unless the natural log is buried inside something else, which is problem 23, which I'm kind of excited to try. There's a problem that's in your homework that when I look at it, I immediately don't know how to do it. I'm going to have to try something. All the other ones I can look at and just know, I can tell, I know I've done it enough that I just know what the answer is going to look like. I may not know all the details, like the positives and negatives, but I know what the answer is going to look like. But number 23, I don't. I have to think about it. So I'm kind of excited to try. All right, so having said that, natural logs make great u's. Then that means this has to be my dv. Okay, so if I set the parts up for you, what's the derivative of, what's du? 1 over x. And what's v? X cubed over 3, or 1/3 x cubed. Okay, I'll set the parts up for you. You guys see if you can finish it. Go. Thank you. Glad I'm wearing this mask. Yeah.
Like with the previous one, if you had done it the other way around with u being kind of sin x dx and then dv being x squared, would it still be solvable that way or would it? Okay.
No. And that's not always the case. Sometimes you can flip them around. But the only ones that you can flip around are the ones that end up in an infinite loop. Like, which I'll show you tomorrow. But this one, if you would have flipped that one you're talking about, Samuel, if you would have flipped that one around, the integration by parts problem that you're left with, or the problem that you're left with right here, would have become more complicated. Like, you know what I mean? Like, the powers on x's would be getting bigger here, not smaller. And then that makes, you're taking this problem and making it harder as you go along. Like, you want this integral to keep getting easier. So how many of us have something like that so far? Okay, perfect. Now, don't get caught up and don't bite on and don't get excited about doing integration by parts again if you don't have to. When you first see that x cubed over 3 times 1 over x, you might be tempted to integrate by parts again, or you might be tempted to throw a natural log in there because you see 1 over x, okay? Don't get emotional there, okay? Hello? Just throw that there. Thanks. You asked me about that folder?
Yeah.
I don't think I have that.
I might have put it in your.
Is it green?
It is green.
Yeah, I don't have that. And I don't have my swim bag today. I left it on the table. Well, I don't know where it is. She doesn't need it now.
No.
Okay. So what do we got to do there? Yeah, just do the algebra. Always look for easy algebra, if there is such a thing. So now, what's the antiderivative of x squared over 3? Billy, what do you think? What's the antiderivative of x squared over 3? Did you say something? So add 1 to the exponent, you get x cubed over 3 and then another 3, so that'll be 9. Sound good? Okay, let's try another one. I think there was an inverse cosine or an inverse sine on your homework. Let's try one of those.
There's an inverse tangent on number 9.
An inverse tangent?
Yeah.
You want to do that one?
Yeah.
Oh, okay.
Sure. It's just.
Was it just straight inverse tangent?
Yeah.
Oh, like unleaded? Now, guys, if you have this problem, you don't have any options, right? Like your choice for you have no options. What does you have to be? Inverse tangent of x. I mean, you have no other options. Okay? Which means dv is 1 dx. Now du, you got to know you got to know the derivatives of those trig. Derivative of inverse tangent is 1 over 1 plus x squared. And if dv is 1 dx, what's v? Just straight up x. Okay? All right. So you ready? So we got u times v. I like to put the simpler one first. Minus the integral of v du. Oh, I forgot my dx here. If you forget it here, no one's going to crucify you. You forget your dx here, okay? But don't forget it here. That's kind of lame. If you forget it there, then you're just being lazy. So how are you going to do that second integral? That looks like the one on the quiz. U sub, right? Alex, what do you want to make U?
X squared.
X squared would work, but I think there's an easier one that is going to be less work in the end. Let's do 1 plus x squared. Okay? Most of the time, guys, when you have a constant like there, and you want to make that the denominator, and that's just going to be your u, just throw that in there with it. So now I'm not integrating by parts again here, right? But I'm still doing a u sub, so I'm going to make sure I keep this clean. Because we might not be able to do that u sub in our heads. And that's okay. So du is 2x. So du over 2 is x dx. Hey, that's the numerator. So this ends up being 1 over u du over 2. Or 1/2 natural log of u. Or 1/2 natural log of 1 plus x squared. Plus c. Well, I guess the c is going to be in the end. So now we got to remember here, the answer to the original problem was this term right here, then minus anything that happened inside that bracket. Now, fortunately for us, there's only one thing that happened inside that bracket. It took a while to get there, but there's only one thing there. So it ends up being x inverse tangent of x minus 1/2 natural log 1 plus x squared plus chips. Yeah.
So we can eat the opposite by a symbol pivot because it can't be negative anyway.
Technically, you wouldn't need it there. You're right. I'm not splitting hairs over the absolute value around the natural log. If you give me this and you put parentheses around that, okay, fine. Even if it required the absolute value. Well, Mia, I think I want to try that problem. What time? See, it's 5. You have 5 more minutes. Yeah. So I'm very excited to try this problem because I don't like. I looked at this problem and I just don't see it right off the top of my head. So I'm kind of excited to try. Right on.
It's the integral
I think it's 23, right?
sine of the natural log
Of 2x. Oh. Okay, now that I wrote it down, as soon as I wrote it down, I was like, oh, now I see it. And you know why I see it? It's for the same reason how we did the last one. There's no other option. Right? Like we have if we're going to do this by parts, you have no option. Because how many functions are there? There's really one. That natural log is inside the sign. So yeah, natural logs make great use, right? But not when they're inside other functions, necessarily. Okay? So I'm going to try it this way and see what happens. So I'm going to say u is sine of the natural log of 2x, and dv is dx. So what's du? Well, it'll be cosine of the natural log of 2x times 1 over 2x times 2, or just 1 over x. So cosine And I'll put my dx there. And I forgot v. Just x. Okay, ready? So here's our answer. I'm going to say the sine of the natural log of 2x equals u times v minus the integral of v du. Now, what's going to happen here with these x's? They're going to cancel out, and we're going to be left with this. Right? The 1 over x and the x cancel out. So what are we going to do?
Live forever.
Well, it won't. You'll see. We're going to integrate by parts again. Okay? Now, I want you guys all to notice something before we integrate by parts again. Did you see how I wrote that? You see what I did when I wrote this that I haven't been doing all along?
The original equation.
I wrote down the original problem. Like, do you see the original problem is written here? I wrote that here. I haven't done that any other time. But I did that because I saw the possibility of the loop that Alex was talking about earlier. Okay, so here we go. Watch. We're probably not going to have time to finish this. We'll finish it tomorrow. So we're going to integrate by parts again, right? So that's when I draw my big bracket. So what's my u? Well, I don't have a choice. It's got to be cosine of natural log of 2x. And then dv is dx. What's du? It's negative sine of natural log of 2x times 1 over x. Okay, I'm simplifying that because I knew that those 2's canceled before. And what's v? X. So here we go. Ready? U times v. Minus the integral of v du. Right? So that minus is from the formula. This minus is from that minus right there. So when I combine these, okay, so before I let you go, because I'm not going to have time to finish this. So I want you to now carry this down, right? This here, then this here, distribute the negative, and then solve for the original problem. Okay? That's where we'll pick up tomorrow. Keep working on these problems, friends. Hopefully today you can do more than you could do yesterday. It's all about growth. You see how you have the same thing here? You can move that to the other side. Now you have 2 of them. Divide by 2. That's how you get Okay. Provided you don't make a sign error. S-I-G-N. See ya. See you later.
gonna have like anything like Delta, now that we're back in school?
You mean for, like, as an assignment?
Yeah.
Possibly, like,
Little assignment.
yeah. I might use Delta Math,